exercises. Question 1. Name the following. 1. Metal which forms an amphoteric oxide. The answer is aluminium. 2. An alloy of copper and zinc. The answer is brass. 3. A compound which is added to lower the fusion temperature of an electrolytic bath in extraction of aluminium. The answer is cryolite and fluorspar. 4. A metal which does not react with cold water but reacts with steam. Answer: aluminium or magnesium or zinc. 5. A common ore of aluminium. Answer: bauxite. Question 2. From the list of characteristics given below, select which are relevant to nonmetals and their compounds. A. Ductile. B. Conduct electricity. C. Acidic oxide. D. Discharged at anode. E. Basic oxide. F. Brittle. G. 1, 2, 3 valence electrons. H. Discharged at cathode. I. 5, 6, 7 valence electrons. J. Occurring in solid or gaseous state. The answer is the characteristics relevant to nonmetals and their compounds are 1. Acidic oxide. 2. Brittle. 3. Discharged at anode. And 4. 5, 6, 7 valence electrons. Question 3. Name one metal each occurring as A. A sulfide. B. A carbonate. C. An oxide. Answer: A. Copper occurs as copper sulfide, that is Cu2S. B. Zinc occurs as zinc carbonate, that is ZnCO3. C. Aluminium occurs as aluminium oxide, that is Al2O3. Question 4. Explain the following terms. 1. Minerals. The naturally occurring compounds of metals along with other impurities are known as minerals. 2. Gangue. Ores contain metal compounds with some of the impurities like soil, sand, rocky material, etc. These impurities are called gangue. 3. ore. The minerals from which metals are extracted profitably and conveniently are called as ores. 4. Metallurgy. The process used for extraction of metals in their pure form from their ores is called metallurgy. 5. Roasting. The process of conversion of sulfide ores into oxides by strongly heating in excess of air is called roasting. Question 5. Give scientific reasons for the following. First, sodium is stored under kerosene. Answer. 1. Sodium is a highly reactive metal. 2. It reacts with the water vapor present in air to form sodium hydroxide and hydrogen. 3. Hydrogen released catches fire in presence of oxygen due to liberation of heat during this reaction. 4. Sodium does not react with kerosene and it sinks in it. 5. Thus, to prevent sodium from coming in contact with air, it is immersed in kerosene. Second, gold and silver are used to make jewelry. Answer. 1. Gold and silver are very expensive and are noble metals. 2. Gold and silver are highly ductile and malleable, due to which they can be beaten into thin sheets or drawn into wires to make jewelry. 3. Hence, they are used to make jewelry. Third, calcium floats over water during the reaction with water. Answer. 1. Calcium reacts less vigorously with cold water. 2. When calcium reacts with water, bubbles of hydrogen gas are formed along with calcium hydroxide. 3. Since sufficient heat is not evolved, hydrogen does not catch fire and bubbles of hydrogen gas formed stick to the surface of the metal, causing it to float. 4. Hence, calcium floats over water during the reaction with water. Fourth, ionic compounds have high melting and boiling points. Answer. 1. Ionic compounds are formed when an atom of a combining metal element transfers its electrons to the atom of another non-metallic element. 2. Thus, ionic bonds are formed between the ions during compound formation. 3. Due to presence of ions, there is a strong electrostatic attraction between the molecules. 4. Hence, to break these intermolecular bonds, a lot of energy is needed. 5. Hence, ionic compounds have high melting and boiling points. Fifth, tarnished copper utensils are cleaned with lime juice or tamarind. Answer. 1. Copper on exposure to air combines with carbon dioxide and a green-colored copper carbonate salt is formed, tarnishing the copper. 2. Lime juice and tamarind contain citric acid and tartaric acid respectively. 3. These acids react with the copper carbonate, forming water-soluble salts which get washed off easily. 4. Due to this, the tarnished copper becomes clean and regains its luster. 5. Hence, tarnished copper vessels are cleaned with lime juice or tamarind. Question 6. Sudha dipped a copper coin in a solution of silver nitrate. After some time, she saw the silver shine on the coin. Why? Give the balanced chemical equation for the same. Answer. 1. Copper being more reactive than silver displaced silver from the silver nitrate to form elemental silver and copper nitrate. 2AgNO3 plus Cu gives CuNO3 twice plus 2Ag. 2. The silver displaced got coated onto the coin, hence the coin got the silver shine. Question 7. Metal A has electronic configuration 281 and B has 2882. Which is more reactive? Identify these metals and give their reactions with dilute HCl. Answer. Metal A with electronic configuration 281 is sodium and B with electronic configuration 2882 is calcium. Their reactions with dilute hydrochloric acid are given below. 2Na plus 2HCl gives 2NaCl plus H2 in the gaseous form. Ca plus 2HCl gives CaCl2 plus H2 in the gaseous form. Thus, they form salts of chloride and hydrogen gas is evolved. Among calcium and sodium, sodium is the more reactive metal. Question 8. To obtain zinc from zinc sulfide, two chemical reactions are involved. ZnS upon roasting gives what? ZnO upon reducing gives what? Write the equations for A and B. Answer 1. Heat or roasting. 2ZnS plus 3O2 gives 2ZnO plus 2SO2 in gaseous form. 2. Reducing. ZnO plus C gives Zn plus CO in gaseous form. Question 9. Translate the following statements into chemical equations and then balance them. First, when steam is passed over aluminium. Answer 2Al, that is aluminium in solid form, plus 3H2O in gaseous form, that is aluminium steam, gives Al2O3, that is hydrogen aluminium oxide, plus 3H2 oxide hydrogen. Second, extraction of copper from its sulfide ore. Answer 2Cu2S, copper sulfide, plus 3O2 oxygen, upon heating gives 2Cu2O, that is copper oxide, plus 2SO2 in gaseous form. 2Cu2O, that is cuprous oxide, plus Cu2S, that is cuprous sulfide, upon heating gives 6Cu, that is copper metal, plus SO2 is released, that is sulfur dioxide. Third, thermit reaction. Answer Fe2O3, that is iron oxide, plus 2Al, that is aluminium, gives 2Fe, iron, plus Al2O3, aluminium, plus heat. Fourth, when magnesium reacts with hot water. Answer Mg plus 2H2O heated or hot gives MgOH twice plus H2 in the gaseous form. Fifth, when aluminium oxide dissolves in aqueous sodium hydroxide. Answer: Al2O3 plus 2NaOH in aqueous form gives 2NaAlO2 plus H2O. Question 10. In the extraction of aluminium, first, name the process of concentration of bauxite. Answer: the process used for concentration of bauxite is called Bayer's process. Second, write the cathode reaction in electrolytic reduction of alumina. Answer: the cathode reaction in electrolytic reduction of alumina is as given below. Cathode: Al3 plus 3 electrons gives Al. Third, write the function and formula of cryolite in the extraction of aluminium. Answer: cryolite, that is sodium aluminofluoride, Na3AlF6, along with fluorspar, CaF2, is added to molten mixture of pure alumina to reduce the melting to about 1000 degrees Celsius during the electrolytic extraction of aluminum. Fourth, write an equation for the action of heat on aluminium hydroxide. Answer: on heating, aluminium hydroxide decomposes to form aluminium oxide and water. AlOH thrice, on heating at about 1000 degrees Celsius, gives Al2O3 plus 3H2O. Fifth, draw the diagram of extraction of aluminium. Sixth, why is it necessary to replace anodes time to time? Answer: during electrolytic reduction of alumina, The oxygen liberated at the anode reacts with the carbon anode to form carbon dioxide. Hence, the anodes have to be replaced from time to time. Seventh, what happens when aluminium ore is heated with concentrated caustic soda? Write the balance chemical equation for the same. Answer. When heated, aluminium ore consisting of aluminium oxide dissolves in aqueous solution of sodium hydroxide, that is caustic soda, to form water-soluble sodium aluminate. Al2O3 plus 2NaOH gives 2NaAlO2 plus H2O. Question 11. Write two methods of preventing rusting of iron. Answer. Iron can be prevented from rusting by first, coating it with paint, oil, grease, or varnish, and second, galvanizing, that is, by coating it with zinc. Question 12. What is an alloy? Give two examples with the chemical composition. Answer. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal in definite proportions. For example, brass, which is 67% copper and 33% zinc. Bronze, which is 88% copper and 12% tin. Question 13. Arrange the following metals in the decreasing order of chemical reactivity: copper, magnesium, iron, sodium, calcium, zinc. Answer. Sodium, calcium, magnesium, zinc, iron, copper. Question 14. Explain the formation of an ionic compound between metal and a non-metal by transfer of electrons with magnesium as the metal and chlorine as a nonmetal to illustrate your answer. Answer. Electronic configuration of magnesium is 2H2, while that of chlorine is 2H7. Thus, magnesium has 2 electrons in its outermost shell, whereas chlorine has 7 electrons. Magnesium loses 2 electrons to obtain a stable octet state and thereby gains 2 positive charges, that is +2, since its atom still has 12 protons in the nucleus and 10 electrons in its orbits. An atom of chlorine has 7 electrons in its outermost orbit and hence gains 1 electron from magnesium to obtain a stable octet state. After gaining 1 electron, chlorine gains 1 negative charge, that is -1, as it has 17 protons in its nucleus but 18 electrons in its orbits. The second electron lost by magnesium is gained by 1 more chlorine atom to form another charged chloride ion. This leads to formation of 1 magnesium +2 positive ion and 2 chlorine minus ions. Magnesium +2 and chlorine minus ions, being oppositely charged, attract each other and are held together by electrostatic forces of attraction. Question 15. An element X, on reacting with oxygen, forms an oxide X2O. This oxide dissolves in water and turns red litmus blue. State whether element X is a metal or a non-metal. Explain with proper example. Answer. First, oxides of metals are basic, while those of non-metals are acidic. Second, since the aqueous solution of the oxide turns red litmus blue, it is basic in nature and hence it is an oxide of a metal. Hence, the element X is a metal.